Welcome to Web Handling. My name is Dave Royson. I'm super excited to continue our new series on zero, which is not nothing. It is something entirely different, as we will see. In this second episode, we discuss the critical difference between web units and machine units by using nip roller pressure as an example. We have a choice in what units are displayed on a control panel. Here I am not referring to the metric versus English units that have been a point of contention for 200 years. The English lost a long time ago, but still have not accepted defeat. Rather, I am talking about machine versus web units. Machine units are the pressures applied to a nip roller cylinder. In days past, this was cheap and it got the job done in some fashion. However, cylinder pressure units are confusing to operators and engineers alike. That is because cylinder sizes vary, as well as assembly weights, geometries, and other factors between nip cylinders on one machine versus another, and even between a nip on one part of a machine versus a nip on the other part of the same machine. Totally confusing for everyone when the same 1 bar of cylinder pressure does different things to the web on different nips. Web units, on the other hand, while derived from machine units, are calibrated and calculated to be work done on the web or the roll itself. Here, 10 kilonewtons per meter or 10 pli will be the exact same work on the web, no matter who made the machine or what it does. 10 is 10 everywhere, all of the time. Let me illustrate the craziness of using machine units by merely changing the orientation of the load direction. Everything else, cylinder size, roller size, arm geometry, and so on, is kept identically the same. Note that on the figure on the left, 0 piston pressure is 0 on the web. However, so too is X piston pressure, 0 on the web. So both 0 and X is 0 on the web. In the right-hand figure, controls are super confusing. That is, 0 rod pressure is max web pressure. Worse yet, more rod pressure is less web pressure. There are 2 solutions to this confusion. Obviously, the very best is to calibrate zero and gain in web units of kilonewtons per meter or PLI in the English system. Computers can do this in microseconds. There is an old school workaround that uses dual piping as described in Web201.81b. While this is a super great idea in any case and for many reasons, it only fixes the 0 part of the problem, not the gain. Now let's move on to the most common and the most confusing web machine, a winder. Winders can have up to 3 TNT controls for wound roll tightness depending on what class they are. These TNTs are web tension, nip pressure, and motor torque. In the old school days, these settings were in machine units. Tension might be dancer cylinder pressure, and nip would be nip cylinder pressure. But 10 on one would not be 10 on the other, as we've just seen. Worse yet, motor torque was in amps or may now be in meter newtons. Contrast that with what winder controls would be calibrated in web units. Tension is in PLI, nip is in PLI, and motor torque is in PLI. Those of you who follow my work know that friction must be measured first before ever doing a calibration. Friction is a measure of the goodness of the cylinder loading design and maintenance. It is also a direct measure of uncertainty. I have a whole series on how to measure friction and do the calibration in these Web 201 shows, so we don't need to do them here. The important point here is that 0 is a definition. It is a safe definition, which is the pressure that always just closes the nip. I hope you've enjoyed this overview of web versus machine units, calibration, and friction. Stay tuned for next week when we will show what 0 is for motor torque, how to find it, and what web units are appropriate. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful, please like and share and subscribe. See you next time.